Hello guys, so today we are going to look at arrays. Alright, so an array is a collection of elements stored in a contiguous, that is sequential memory locations. So we are also going to look at how we can declare an array. So declaring an array, 1, we have the data type, 2, we have the array name, and 3, we have the size of the array. Now the data type is the kind of values that the array can store. So for example, we have integers, we have the float, which is the floating point, the decimals, and we have the char, which is the character. Okay, we also have the array name to identify the array. Then we have the size, the maximum number of values the array can hold. That is the size of the array. So this is a typical representation of implementation of the array. We have the data type, the array name, and then the size. So mind you that the size here is 5. Okay, so to better understand this, let's see how it is represented in the computer system. Okay, so yes, so this is it. Our first element here, this our first element, our second element, our third element, our fourth element, then our fifth element. Yes, so this is how it is done. The first elements always correspond to the index 0. The second element corresponds to index 1, third to index 2, fourth to index 3, and then fifth to index 4, and so on. So depending on the values that you have, right? So to better understand this concept, let's try and then solve question under arrays and see. So given the array max, and then these are the values of the array, we are to calculate the address of max 4, that's the index 4, if the base address is 1000, and calculate the length of the array. Okay, so here first thing that we need to do is that we are going to input these values inside the table. So our first value, which is 99, second value, which is 67, our third value, which is 78, our fourth value, which is 88, our fifth, sorry, I think we missed a number here, so let's correct that. Right, let's delete okay, then 56, so here is rather 78, so 78. Then we have 56, we have 88, we have 90. Yes, so we corrected that. All right, so and then the first element always corresponds to the index 0, the second element to index 1, the third element to index 2, the fourth element to index 3, the fifth element to index 4, and the sixth element to index 5. Yes, so with this in mind, let's go ahead and then calculate the address of max 4. Okay, let me switch to an empty space and then let's paste a question there, a data. Yes, okay, so now we have the data, and then we always know that the first element corresponds to 0. All right, so we have to calculate the address. So address of k is equal to BA plus W into brackets K minus LB or B. Okay, so the AK is the address of the array, the BA is the base address, the W is the size of the address, the K is the index of the element, and then the LB is the lower base of the array. So here we are looking at 4. Alright, so A4 is equal to our base address. Let's go back to refer to. So our base address was 1000, right? So let's place 1000 there plus our W. So our W is the size of the elements. So storing an element in int typically requires 4 bytes of memory space. So 4 into bracket, and then our K, which is the index, which was 4. So let's go back and then refer to that. Okay, so max 4, so that is our index. that is the W, sorry, our K. So 4 minus the LB, which is the lower bound. So when we check, we can see that the lower bound is obviously 0. Alright, so let's place in 0 there. Let me select the marker. Alright, yes. So let's place in 0 there, then close our bracket. Now let's simplify this. We have 1000 plus 4 by 4 is 16. Yes. Now we add them, we have 1016, that's 1016. So this tells us that the fourth element, right, has an address of 1016. Then we can confirm that from the table there. Yes, good. And then we also asked to calculate the length of the array, right? So length is equal to u b. So let's do this. So the length of an array is always given by the upper bound, is ub, minus the lower bound, which is lb, plus 1. Good. So let's erase this so we get space to continue our solution. Sorry, let me take this off. Okay. We're almost there. Okay, I think this space is enough. Right. So now we have our formula. We just have to substitute in the values. Alright, so let me select the marker and then we could finish it up. Okay, yes, so our L, which is the length of the array, is equal to the upper bound. Yes, now let's go back and then refer to the upper bound. So the upper bound here is 5, as we can see from there. So let's just substitute that into it. So we have 5, right? Let me select this. So 5 plus the lower bound, which is obvious, the lower bound was 0, and then plus 1. Good. So we have our L to be 6 arrays. So this tells us that the length of the array is 6. So we have 6 elements. So let's confirm this. So our first element takes index 0. So this becomes our first element. This becomes second, third, fourth, we have fifth, and then finally sixth. Good. So this confirms our answer that we had, which was 6 elements. So it tells us that this array has 6 elements. Very good. It has 6 elements. Alright, so this is how we go about arrays and then how we can implement arrays. If you have any question, you can put it in the comment section and then we would attend to that. Don't forget to smash that subscribe button and like this video if it helped you.